Good day, everyone, especially to you, Ma'am Krisha Maydela. We are the Group 1 reporter, and in this video, we are going to discuss about the spectroscopy. It is a field of science that study the interaction of matter and the electromagnetic. It is also a technique that used to identify and quantify the chemical composition of solution. It is a precise study of color as generalized from visible light to all bands of the electromagnetic spectrum. So, spectroscopy is all about how matter and light interact. It helps us analyze and measure chemicals in different substances. By studying the different wavelengths of light, we can identify the chemical composition of a substance. Like, for example, in chemistry, spectroscopy is used to determine the structure and properties of molecules. And, it, and it's also used in environmental monitoring to analyze pollutants and also in astronomy to study the composition of stars and galaxies, and in medicine to diagnose diseases. So, spectroscopy is a powerful that helps us understand the world around us.
Atomic and molecular spectroscope. Atomic and molecular spectroscope are branches of analytical chemistry that study the interaction between electromagnetic radiation and matter. They involve techniques to analyze the atomic and molecular composition of substances by measuring the wavelength and intensities of emitted or absorbed electromagnetic radiation. These techniques are widely used in various fields such as chemistry, physics, astronomy, and environmental science for identification, quantification, and structural analysis of substances. There are three main types of atomic spectroscope. First is atomic absorption spectroscope or AAS, then atomic emission spectroscope or AES, and atomic fluorescence spectroscope or AFS. So unsay gamit aning atomic spectroscope? Kaning atomic spectroscope is an excellent analytical tool used for the detection and measurement of elements in the sample with high precision and confidence. Atomic spectroscope mainly consists of two types of techniques: atomic absorption spectroscope and atomic emission spectroscope. Atomic and molecular spectroscope is a powerful tool to analyze chemical composition or structure of a substance, which may be a pure compound or simply mixture of solution of two or more different phases of a crystalline or amorphous material. So, what is atomic and molecular spectroscope? It is one of the widely used analytical techniques to study the structure of atoms and molecules. The technique is also employed to obtain information about atoms and molecules as a result of their distinctive spectra.
Vibrational spectroscopy is a key analytical technique used to study molecular vibration in compounds. It includes two main methods: infrared spectroscopy and Raman spectroscopy. In IR spectroscopy, molecules absorb infrared radiation, revealing information about their structure and function group. Raman spectroscopy involves the scattering of light to analyze molecular vibration, particularly used for inorganic compounds. Both techniques are non-destructive, require minimal sampling preparation, and are widely applied in chemistry, biology, pharmacy, and material science for qualitative and quantitative analysis. Nuclear magnetic resonance spectroscopy is a powerful analytical technique used to study the structure, dynamics, and interaction of molecules at the atomic level. It is based on the principle of nuclear magnetic resonance, where nuclei within an odd number of protons or neutrons have magnetic moment and can absorb and emit radiofrequency radiation in a magnetic field. So I can give at least two use of magnetic resonance. One is structure determination. NMR spectroscopy is widely used to determine the three-dimensional structure of organic molecules, including complex proteins, peptides, and smaller organic compounds. By analyzing the chemical shapes, coupling constants, and peak integrals in the NMR spectrum, scientists can elucidate the connective of atoms in the molecule. And the second one is the quantitative analysis. NMR spectroscopy is used for quantitative analysis of compounds in solution. By measuring the intensity of NMR signals, researchers can determine the concentration of compounds, study reaction kinetics, and monitor chemical reaction in real time.
Spectroscopy is a powerful scientific technique that involves the study of the interaction between matter and electromagnetic radiation. Principles of spectroscopy. First, interaction of electromagnetic radiation with matter. Spectroscopy involves the absorption and emission of light and radiation by matter. It focuses on how these processes depend on the wavelength of the radiation. The emitted or absorbed radiation is analyzed by separating it into various frequency components using instruments called spectrometers. Second, emission and absorption spectra. An emission spectrum is produced when a substance emits radiation after absorbing energy. An absorption spectrum is formed when radiation is absorbed by a substance, leading to dark spaces in the spectrums corresponding to the absorbed frequencies. Third, types of spectra. Spectra can be continuous, line, or band spectra. Continuous spectra are produced by sources like the sun, while line spectra are characteristics of excited atoms in the gas phase. Band spectra are emitted by excited molecules in closely spaced lines. Fourth, significance of spectra. Spectra provide valuable information about the structure and composition of matter, aiding in chemical analysis and understanding electronic and nuclear structures. Spectroscopy plays a crucial role in identifying elements and compounds, elucidating atomic and molecular structures, and studying particles like electrons and ions. Fifth, quantitative parameters of spectra. Each spectral line is a spectrum is characterized by its position, intensity, and line length. Sensitivity and resolution are key parameters used to describe the quality of a spectrum. Sensitivity relates to distinguishing signals from noise, while resolution refers to the ability to differentiate adjacent spectral signals. Sixth, relationship between energy, frequency, and wavelength. Quantum physics provides relationship between energy, frequency, and wavelength of particles. The energy of quantum particles is proportional to its frequencies and inversely proportional to its wavelength. Spectroscopy is not only essential for identifying elements and compounds, but also has diverse application in various fields like chemistry, biochemistry, physics, and environmental science. Understanding the principle of spectroscopy enhances our ability to analyze and interpret the interaction between matter and radiation effectively.
Application of spectroscopy. Chemical analysis. Chemical analysis for the qualitative and quantitative analysis of chemical components in variety of samples. Spectroscopy is widely utilized. It makes it possible to characterize molecular structures, determine concentration, and identify unknown chemicals. The next one is the environmental monitoring. Environmental monitoring is a tool for pollutant detection and quantification, soil composition analysis, air and water quality monitoring, and the study of environmental processes like atmospheric chemistry and climate change. Spectroscopy is essential of environment science. So the next one is astronomy and astrophysics. Astronomy and astrophysics. In the fields of astronomy and astrophysics is spectroscopy is essential of determining the makeup, velocity, and temperature of celestial objects. Astronomical spectroscopy sheds light on the features of exoplanets and early cosmos in addition to the chemical makeup of stars, galaxies, and interstellar stuff.
Medicine and biology, diagnosis and monitoring of these cases, drug development and biomolecular studies. In spectroscopic methods in biology and medicine continue to expand our knowledge of biological system at the molecular level, resulting in advances in biomedical research, diagnosis, and therapy. So next is material science. Material science characterization of the structure and properties of materials. In a key instrument in material science for examining a material's atomic and molecular structure, composition, and other characteristics is spectroscopy. It includes a broad range of methods that offer insightful information on how materials behave and if they are appropriate for different uses.
Instrument that measure the intensity of light as a function of its wavelength. This versatile tool plays a crucial role in various scientific fields, including chemistry, physics, and material science. Let's start by understanding the common technique used with spectrometers. Number 1. Absorption spectroscopy. This technique measures the absorption of light by substances, providing valuable information about the substance chemical composition. Number 2. Emission spectroscopy. Unlike absorption spectroscopy, emission spectroscopy measures the light emitted by a substance when it is heated or excited. Number 3. Raman spectroscopy. This technique is used to identify and study the molecular structure of substances. Number 4. X-ray spectroscopy. X-ray spectroscopy is used to analyze the chemical composition and electronic structure of materials. Number 5. Mass spectrometry. This technique measures the mass charge ratio of ions to identify the composition of a substance. It is widely used in fields such as forensics, environmental science, and pharmaceutical for analyzing complex mixture. Each of these techniques offers unique insight into the properties of materials, making spectrometers essential tools for scientific discovery and innovation. The versatility of spectrometers and the wealth of information they provide continue to fuel advancement in numerous scientific fields.
Furthermore, spectroscopy is a fundamental technique in the field of analytical chemistry and physics that plays a crucial role in studying the interaction between matter and electromagnetic radiation. The importance of spectroscopy lies in its wide range of application and its ability to provide detailed information about the composition, structure, and properties of matter. Spectroscopy is a versatile and powerful tool that provides valuable insight into properties and behavior of matter across different disciplines. It's important in scientific research, industry, environmental monitoring, and healthcare underscore its significance in advancing knowledge and technology.
Spectroscopy has several advantages that make it valuable analytical technique. Firstly, it is highly sensitive, meaning it can detect even small amounts of substances. This sensitivity allows for the detection and quantification of trace elements or compounds in a sample. Secondly, spectroscopy is non-destructive, which means it can analyze samples without causing any damage to them. This is particularly beneficial when working with valuable or irreplaceable samples. Another advantage of spectroscopy is it is rapidity. It provides results quickly, allowing for timely analysis and decision making. This makes it suitable for application where real-time monitoring or fast analysis is required. Additionally, spectroscopy is a versatile technique that can be used to analyze a wide range of samples, including gases, liquids, and solids. It can be applied in various fields such as chemistry, physics, biology, and environmental science. However, spectroscopy also has some limitations that should be considered. One limitation is the required for special equipment. The spectroscopic instrument can be expensive and may require trained personnel to operate them effectively. Another limitation is the complexity of data interpretation. Spectroscopic techniques often generate complex spectra that need to be carefully analyzed and interpreted. This requires expertise and can be time-consuming. Furthermore, spectroscopy can be affected by potential interference from the other substances present in the sample. This interference can lead to inaccuracies in the result that may require additional steps or techniques to overcome. It's essential to understand and account for potential interference which using spectroscopy for analysis.
Spectroscopy have also a limitations. One, we have a complex data interpretation. The data from spectroscopy can be complex and require significant expertise to interpret correctly. And the second one, we have a sample preparation. Some samples may require extensive preparation or specific condition for accurate analysis. And the third one, we have a instrument cost. High-quality spectroscopic instruments can be expensive to purchase and maintain. And the fourth one, we have interferences. Spectral interferences from other substances in the sample can complicate analysis. And the fifth one, we have limited by physical properties. Certain techniques are limited by the physical properties of the sample, such as its capacity or fluorescence. In the other one, we have calibration requirements. Accurate spectroscopy often requires regular calibration and the use of standards. And the last one, we have environmental factors. Conditions such as temperature, pressure, and humidity can affect spectroscopic measurement and need to be controlled or accounted for.
Okay, so let's have the conclusion of the spectroscopy. Okay. In conclusion, spectroscopy is the study of absorption and emission of light and other radiation by matter, involving splitting of light, or more precisely, electromagnetic radiation, which is done in much the same time as a prism split into a rainbow of colors. So, in akong sa kwan pa siya, ang ako siyang in a short or in a brief word is this is the study of the light, or the absorption or the reflection. Like say for example is when the sun rays light, so when you put the prism or butang nimo ang prism, like prism is like ay kana bitaw siyang kwan like in the shape na is triangle but also a colorless or white tanan. Then once nga imo na siyang ipa-reflect or ipaigo sa sunlight or sa sun rays, so ang reflection na mao na siya ang kanang mga color na light. Ang color ng mga reflection is the rainbow, mao na siya nga online line of color. So mao na siya ang kanang should be study of the kwan, like studian lang about sa life or the reflection of the light coming from the sun rays reflect into the prism. Okay, so using spectroscopy, so we can get the information and kind of source radial velocity composition including ions and molecules, and temperature from position and intensities of line, and rotation from shape of line. Example from the sun and other stars. So as I've said before, like kanina, diba? So we can get the information, the radiation or the source coming from the sun, or the other example is the coming like example the stars or the suns or other coming from the natural resources. So dira man gud makita gud kanang dira na makita bitaw kung unsa gyud ang true color sa isa ka butang, true color sa isa ka objectives once nga imo siyang ipaigo sa init or ipaigo sa sunrise, ipa-direct na pwede pa center. So mag-reflect mo na iyang color. So once ka ma-reflect na iyang color, so diya gid mo makita iyang true nga color. So yes mo na. So to detect, determine or quantify the molecular and or structural composition of example, each type of molecule and atom will reflect, absorb or emit electromagnetic radiation and its own characteristic way. O saba, so ang giingon pa dadari, so ang conclusion ko no is kana bitaw, once nga kanang unsa imong characteristic, once nga imo siyang kanang paigo sa sun rays mo, nang once nga ini reflect ana makita na imong characteristic, imong own true colors. Let's say butang na to kanang way nganong ang mga colors kanang mga sample ka ng mga dahon ng green kaayo. So once ka nang imo na siyang mainitan, so mo nang once ka initan siya, pag reflect ka na mo nang ilang color green mo nang makita ang ilang true color. Na mo ra gyapon na example sa kwan kaning mo gyapon in the same sa when talks about chemistry. Once nga ang prism imong ipaigo sa sun rays, so mo nang mag-reflect siya og rainbow mo ng color. So in short, spectroscopy is a study of reflection about what characteristic who you are. Like once nga kanang mag-reflect na ang kanang light or magpaigo ka sa kuan sunrise, so og unsa na ang reflect sa imong color, mao na imong true nga color, mao na imong true nga characteristic. That's all.